We're gonna go on to the next section. Okay. And last year I only did today. We're getting a little bit further this year than we did last year. So I only did today's lesson. I'm like doing you for tomorrow and Monday. So I can't tell you guys exactly. You'll just kind of have to gauge how you feel it is. I don't know that they're kind of what we're doing today, tomorrow, and Monday. Not the very first part I show you today, but then after that, you're kind of doing like mini kind of proofs. Oh, no. They're not like 2-column like in geometry, but especially what we do on Monday, you're trying to get the left side of an equation to equal the right side. So I can't say that this is way easier than what you had been doing. Like I thought what you guys had a quiz on yesterday was kind of tough. Did you think that?
No.
Yes.
I'm not sure that this would be harder for you, but I can't say that for
You think
sure.
this is harder than Ms. Bott, did you grade it?
I don't know. Oh, yes, I need to tell you that too. I forgot my key when I left here last night, so I haven't even looked at your test yet. So I'll look at them tonight. But I can't say that I'll have them done for sure tomorrow, but I'll try my best. Okay? All right, so what we are going to do, did anyone take their cheat sheet out? Is we're going to talk about some trigonometric identities. And if you look at this page right here.
Is that in our cheat sheet?
Yes, and I can print, the only thing you'll need is these 2 pages, and I can just print those back to back so you only have 1 sheet. But we're going to be using over today, tomorrow, and Tuesday, these things here, okay? Oops. And this thing right here you can ignore, but the rest of it is what we will be talking about. So the first thing, you guys should know these already. Do you know the reciprocals, like that sine and cosecant are reciprocals, and cosine and secant are, and tangent and cotangent? Everybody okay with that? Now, this right here is something we will use. This is something we'll use a lot the next 3 days. Tangent is equal to sine over cosine. It's called an identity, a quotient identity. And then cotangent is cosine over sine. So tangent is sine over cosine, cotangent is cosine over sine. And what you'll do is you'll probably get to know, like by the test, you'll know this and this. Okay, then down here, these are called Pythagorean identities. And if I look here, okay, this is the actual identity. Whenever you see in one of these problems sine squared plus cosine, it's 1, okay? Then what I did these 2 is I solved this for sine. Because another thing that will happen is sometimes in one of these problems, you'll see 1 minus cosine squared, and that can be substituted with sine squared. And then this 1 minus sine squared can be substituted with cosine squared. These 3 are I'm guessing by the time you take your test next Wednesday, you'll know these 3 by heart, okay? Then the main other identities are these 2. So tangent squared plus 1 is secant squared. And then what I did down here is I solved this for tangent squared. And then this one I solved for secant squared. And then this is another one. Cotangent squared plus 1 is cosecant squared. And then I solved it for cotangent squared, and I solved it for cosecant squared. Okay? So you don't have to memorize them. You'll have that cheat sheet, but those are things that you will do. So this is the first type of problem that you guys are gonna see. They're gonna ask you to find the exact value of cosine theta. When they say exact value, that means you can't put it as a decimal. You have to put it as a fraction. Sometimes you'll have a square root in there and you have to leave it in there. If sine of theta equals this, and what this says is they're telling you what quadrant you're in. I think you guys all know this is 0, this is 90, this is 180, this is 270, and this again would be 360. What this is going to tell you basically is what quadrant you're in. And do you get between 90 and 180, aren't you in quadrant 2? Now, in quadrant 1, all of the trig functions are positive. In quadrant 2, it's sine and the reciprocal of sine. Do you guys know what the reciprocal of sine is? Cosecant. Those are the two that are positive in the second quadrant. In quadrant 3, it's tangent and it's reciprocal. What's the reciprocal of tangent? Cotangent. So these are both. And then calculus starts with C. So if you notice that the way to memorize this, if you had to, these are all. Student starts with S, and sine is the one that is positive here. Take starts with T, and tangent's positive here. And then this can be calculus, chemistry, whatever. Calculus starts with C, so that's cosine. Cosine is positive and it's reciprocal, which is secant. So that's something you'll need to know. Now, here's what you do. If they give you sine, you're gonna put that into the Pythagorean identity that has sine. And what I mean by that is back down here, it's this one here. Okay, so we're gonna go back there and we're gonna say sine is 1/4, and I have to square that, plus cosine squared, because I don't know what that is, equals 1. And then I'm gonna go ahead and solve that. Now, do you guys know when you square 1/4, you'd square the one on top, 1 squared is 1. 4 squared is 16. And that's plus cosine squared. If you don't want to keep bringing this theta down, you can just kind of forget about that, and it equals 1. Okay? Then we're going to subtract 1/16. Okay, and we get cosine squared equals. Now, when they say exact value, what that means is you can't just go 1 minus 1/16 on your calculator and leave it as a decimal. But what you can do, if you're not good at subtracting fractions, if you have a graphing calculator, you can go 1 minus parenthesis, was it 1/16? Parenthesis, write it like that. And then if you do math, enter, it'll put it as a fraction for you. If you're not good at subtracting fractions, just do that. Everybody understand how to do that? Okay.
I think you just got a long time ago.
I did? Okay.
Right.
Oh, why did I never show you that?
Oh, you did. I'm just saying in general, they should just show us that.
It only works with a graphing calculator, I think. But, okay, so now, do you guys get when you have cosine squared, if you want cosine, what would you do? Square root. Okay, so here is what you would do. The square root of cosine squared is just cosine. But when you're taking the square root, one of the things we have to take into account in these problems is the square root can be plus or minus. Okay, so we're going to put that in front. On top, the square root of 15, there's nothing I can do with that, so I'm going to just do 15. What's the square root of 16? 4. Now you want to see if you can reduce that at all. And what I mean by that, do you guys remember if you have a number under a square root, that there's a perfect square that divides into it, you would have to do that and take out whatever the square root of that is. So what you would think of is there a perfect square like 1, 4, 9, 16 that divides into 15? It doesn't, okay? Then that means this is reduced as much as it can be. And then what you have to do is figure out what sign would cosine have in this quadrant, okay? So here we are in the second quadrant. Do you see how sine and cosecant are the only two that are positive? Doesn't that mean cosine is going to be negative? So cosine is going to be, I'm actually write this over here. So cosine is going to be negative root 15 over 4.
Wait, how do you tell?
Okay.
Oh, never mind, I got it.
Because you're between the 90 and 180, only sine and cosecant are positive in that quadrant, and we have cosine, so it's negative. And then that is your answer. Are you guys okay with that? Okay. Then if we go to this here, notice I have cotangent. When you have cotangent, you want to go back to these three identities and you want to find the one that has cotangent. So we've used this one right here, okay? So if I go back and go down to that, they're telling me the cotangent is negative 3/5, and I have to square that. Plus 1 equals cosecant squared. And like I said, you don't have to keep following that theta down, you can just kind of drop that off. Now, when I square this, what happens when you square a negative? Positive. And then you have 3 squared is 9, 5 squared is 25. Then we have the plus 1 equals cosecant squared. Now, again, if you have a graphing calculator, which you can always borrow mine if you don't have one, you can go parenthesis 9 divided by 25 parenthesis plus 1. Oh, and what I forgot, math, enter, enter, and then you get 34/25, okay? If you don't have that, just so you know how you would do this, you'd go 9/25 plus, do you get that? You could write 1 as 25/25. 34. So then this is 34/25 equals cosecant squared. Then what would I do to that? Square root. So I'm going to take the square root over here, and I'd get cosecant equals, and you have to remember that it could be plus or minus, okay? Is there a perfect square that goes into 34? Like 4, 9, 16, 25. Do any of those go in there evenly? So that means you keep that square root of 34 on the top. How about the square root of 25? What's that? 5. Now, you can keep that like this. This is reduced. All we have to figure out now is would the cosecant be plus or minus in this range? Do you guys get? This is 90, this is 180, this is 270, this is 360. So this range is this quadrant right here, right? And in here, cosine is positive and its reciprocal, which is secant, is positive. So what would our cosecant be? Wouldn't it be negative? Do you guys get that? Only cosine and secant are positive in this quadrant, so cosecant is going to be negative. So what we would say then is our cosecant is going to equal negative root 34 over 5. You guys okay with that? All right. Now we have one where we have to find tangent, and then we'll get into the second type of problem. So this one has secant. So if it has tangent and secant there, you'd want to go to your identities. And notice it's this middle one, because this has tangent and secant, okay? Then what I would do, tangent is what I'm trying to find. I don't know that, okay? Plus 1, and they tell me my secant is negative 2. All right, so then I have tangent squared plus 1 equals, what's a negative 2 squared? It's a positive 4. And I just want to tell you this because this is something I see happen a lot. If you went on your calculator and you went negative 2 squared like this, it's going to say negative 4. How can you prevent that from happening? Parentheses. So you can go parentheses, negative 2, parentheses squared, and it's positive 4. Okay? So now this is 4. And then I just solved that. I subtract 1. This one's going to be easier than the others we did. So we get tangent squared equals 3. And then what would I do? Square root. So when I take the square root here, I get tangent equals plus or minus. Can I reduce square root of 3 at all? So it's just root 3. And then we look at what quadrant are we in. If it's 180 to 270, isn't it this one, right? 180 is here, 270 is here.
Positive.
Isn't tangent and cotangent going to be positive there?
Yeah.
And this is tangent, so wouldn't it be root 3? Everybody okay with that?
Yeah.
All right, so now we're gonna go to the, I don't know if you have a page 4, but go to the page that looks like this. I think these are easier than what I just showed you because they're quicker, but we'll see what you guys think, okay? So kind of the rest, tomorrow we do a couple like I just did, but the rest of the chapter is going to be simplifying different trig ratios, okay? And what you try to do is get these to be simplified as much as you can, all right? And the hint is, and the examples that I'm going to use, is you always take these and you want to simplify them and get them in terms of sine or cosine. So no matter what you have, you want it to be in terms of sine or cosine. So if I look at this one here, this is already sine. And again, that theta, you don't have to bring that down. You can ignore that. Now, secant, can I write that in terms of sine or cosine? What is secant? Isn't it 1 over cosine? Okay. So what I'm going to write that as is 1 over cosine. Now, when you do this, you basically just multiply across the top and you get sine. And on the bottom, you have cosine. Once you get to that point, you want to see, could you write that as something else? Because you want to simplify it as much as you can. What is sine over cosine? Sine over cosine is tangent. Mason, if I were you, I would not be watching that. So this is going to simplify down to tangent. So you put everything in terms of sine or cosine as you're simplifying, but then that last step, you try to see, how can I rewrite this? And because this has 2 things and this has 1, you want to simplify it as much as you can. So now let's look at this one. Think of cotangent. How can I write cotangent in terms of cosine or sine or both? Couldn't I write cotangent as cosine over sine? Okay. So cosine or cotangent is cosine over sine. Okay. What is secant? Isn't secant 1 over cosine? Okay. I said, put your phone away. Secant is 1 over cosine. All right. Now, can you simplify that at all? Cross out the cosines, right? Because you have a cosine on top and you have a cosine on the bottom. And now I have 1 over sine. Can I write 1 over sine as something else? Secant. Or cosecant. Cosecant.
Oh, you're scared, Aaron.
Do you get that?
Yeah.
Okay.
I have no clue what these are.
Okay.
I don't know that words of them.
Okay.
CSC.
Now, do you remember how you want everything to get in terms of sine or cosine? This is cosine. How do I write secant in terms of sine or cosine? Yep, it's 1 over cosine again. So if I go back here, whoops,
Oh my goodness.
it's 1 over cosine. Okay? Now, whenever I have a division like that with a fraction, do you guys get how this is really cosine divided by 1 over cosine? Right? Which it's cosine times cosine. Do you get that? Because I changed this to multiplication and I flipped my fraction. And what's cosine times cosine? Cosine squared. And that's your answer. So like if you're thinking like, how do you know where to stop? Do you see how this is one thing? When you get something down to one thing, then you know you're done. Okay? All right, so let's go to our last page. Oh, not quite, we have 2 pages left. So if I look at this right here, okay, I have a sine, a cosecant, and a cotangent. So you can tell they're getting a little bit more. And as we go through tomorrow and Tuesday or Monday, they're going to get more and more. So do you guys get that I could leave this sign? But I need to rewrite that cosecant in terms of sine or cosine. What is cosecant? 1 over sine. Okay, so I'm going to go back, and cosecant is 1 over sine. Then on the bottom, do you remember what cotangent is? It is 1 over tan, that's true, but you want to write it in terms of sine and cosine. So you'd want to use this one, okay? So we would write cosine over sine, okay? Now, do you see it? Don't these 2 cancel? And actually, this one, if you hadn't changed the cotangent, let me just show you this. If you ever realize this, say that we hadn't changed that yet. If I just left it like that, do you guys get that? Isn't this like 1 over cotangent? And what is 1 over cotangent? Isn't it tan? So if you saw that there, you could certainly have done that. That would not be wrong. But if you didn't see that, okay, because you guys are just kind of getting used to this, what you would do is you'd write it as sine times 1 over sine divided by cotangent is cosine over sine. Do you guys get these signs are gonna cancel? So you'd get 1 divided by, or is it confusing to you if I change this to 1 divided by cosine over sine?
Yeah.
You get that? And then it would be 1 times sine over cosine, right? So isn't that just going to be sine over cosine? Which, how can I write that? It's tan. So either way would be fine. But when you guys do the quiz, this is the part, like, I think somebody was asking me, like, how many points? You're not just graded on the answer. You need to show your work to get to the answer. The process, you're getting points for.
You ever things graded?
No, I haven't even looked at them. Okay, so if we look at this, okay, how can I write tangent in terms of sine and cosine? Sine over cosine. How do I write cosecant? 1 over sine. Very good. And then I'm dividing that by secant, and how do I write secant in terms of sine or cosine? 1 over cosine. Okay. Now, do you guys tell here, wouldn't your sines cancel? And don't you have then 1 over cosine on top and 1 over cosine on the bottom? What do you think happens to both of those? They cross out, and so what would you be left with? 1. This is the same thing as if you had cosine divided by cosine. Do you get it would be 1? Anytime you have the same thing on top and bottom, they would just give you 1. Are you guys okay with that? Somebody said not really. Do you get how we got this? Okay, do you get how I got from here to here?
Got your deflated balloon.
Okay, and then this is this. Do you see how these two things are identical? Anytime you go like 7 divided by 7, it's 1. X divided by X is 1. So this is divided by itself, it's just going to be 1. Okay? All right, let's look at this one. How can I write secant in terms of sine or cosine?
1 over cosine.
Very good. And then that's divided by sine. How can I write 1 minus cosine squared? Now, we have not done this, but when you see 1 minus cosine squared, that you're going to have to get used to this chart. 1 minus cosine squared is sine squared. Okay? So back here, this is going to be times cosine squared. Now, a couple ways that you could do this. You could either
Forget sine squared.
Sine squared.
Oh, I'm sorry. Yeah. Sorry. Okay. Couple ways you could do this. You could work on simplifying this, or do you guys get, like, this is really over 1, and I could kind of think of this on the top, and isn't this like sine squared on top, and then cosine on the bottom? Just the top. Do you get that?
Wait, where is the cosine in this one?
I'm just kind of multiplying across the top on both of those.
But why determine sine over squared?
Okay, 1 minus cosine squared is this. 1, Caleb, 1 minus cosine squared is sine squared. So did I confuse you guys when I kind of combined these together? Because I wouldn't have to do that.
So you can use sine over 1 and if we put it over again.
This was times sine squared. Okay, right? So we don't have to, if it confused you to combine these tops, we could just simplify this first,
Let's do that.
okay? Do you guys get that over here, this is 1 over cosine divided by sine? And it's times sine squared. Okay? Do you understand that? All I'm doing is I'm going to keep this simplifying, and this is sine squared. Now, when I can rewrite this as a multiplication problem. And do you get that I would have then the reciprocal of sine over 1 is 1 over sine times sine squared. Okay, now can I cross something out? One of the signs, right? So do you get I could scribble out this 2 and scribble that? So what I'm left with is 1 sign on the top. Do you understand that? I had 2 on the top and 1 on the bottom. So what I did is I scribbled out that 2, so I only have 1 there, and I crossed that one out. So then on the top, I have sine. On the bottom, I have cosine. And isn't sine over cosine tangent?
Are we finally done with this?
I have 1 more, right? 3 more problems. 3 more problems.
No.
Okay. Okay, how can I write 1 minus cosine squared? Sine squared. Do you guys understand that? 1 minus, was it sine? 1 minus cosine squared is right here. And it's sine squared, okay? Then tangent, how can you write tangent in terms of sine and cosine?
Sine over cosine.
Sine over cosine. And then we still have on the bottom that sine. Okay? Do you guys get, now I could say I still have sine squared on top. And do you get, like, I could multiply these on the bottom? Sine times sine is sine squared divided by cosine. Everybody okay with that? I just kind of thought of this sine as sine over 1. I multiplied that, and on top bottom I have cosine. So now that is sine squared divided by sine squared over cosine. And what do I do when I switch that division? Yeah, and I flip this, right? So it'd be cosine over sine squared. And then it's Grady, right? Would I cross out my sine squared? Okay, and I would be left with cosine.
Cosine.
Yeah, you could write cosine over 1, yeah. Okay, this one's going to be quick. What's sine squared plus cosine squared?
Tangent squared. 1 over.
Sine squared plus cosine squared is 1, right? And then, what's 1 minus cosine squared? Sine squared. Now, what do you guys think we could do with that 1 over sine squared? What did you say? Not cosine, but cosecant squared. Do you get that? Because isn't cosecant 1 over sine? Right? So if you have, we have 1 over sine squared, so that we could write as cosecant squared. Okay? Now, so this is cosecant squared. Then 1 more. You know what? Actually, when I was doing this one today, this is kind of yucky. Should we skip this one?
Yeah.
And then hopefully you won't have one like this on the worksheet, but if you get stuck, let me know. We'll skip this one. All right, so I have a worksheet for you today.
I got it stuck.
That's one big pencil.
It's It's good size.
It looked like a triple.
So how was it today? Hard?
About an hour and a half.
Okay.
Where's the answer key?
Are you guys all taking them?
Yeah.
Did you understand?
Little.
Oh my gosh. Do you guys all read it?
Oh, no, I didn't like a teacher. What's a piece of gum?
But I guess it's cool. You know
Yeah, you should drink more milk.
Oh, wait, is it you?
what? What?
Oh, man.
Yeah, I don't know if I use mechanical.
May I please have a piece of gum?
You guys, I do have a key for this.
Do not eat that, Aaron. I'm looking out for you. Do not eat that.
Where do they come?
It's the ground.
Yeah, did I? Oh, no, the square to 16 is 4. Yep. All right, take a seat. Don't need to write on my board.
If you get a disease, no. No, don't eat.
Trust me, Aaron.
No. I get in my class today and get rid
Worms are worms.
What are worms? What are they? Worms. What are they?
But don't we have to? That dog's supposed to. What's going on here? Too many people are gathering around that you only need one person to take pictures.
Horrible pictures.
Bro,
Let her take a picture.
let me take a picture.
Caleb Creed.
Call.
Peter,
I have aqua as well.
Peter, what'd you do for number 4?
It's on my legs.
Skip to the easy stuff. That's an arachnid.
No, arachnid.
8.
No, arachnid.
Hold back. Huh?
No, insects or species. Yeah. Then what are and 6 legs? Well, there's different types of bugs. Like arachnids have 8 legs.
No.
Are you sure there's any? So there's nobody. A grasshopper. A grasshopper. Oh, they don't. The big one in the back. That's 4. Two sets of. No, they don't. Hey Siri.
So, when they don't have.
How many legs do grasshoppers have?
Why don't you? They have 4.
How many legs do grasshoppers have?
I grasp 3 halves. Sign them to face.
Ha! 6 legs. Siri says so. Ha!
I could have sworn they had like front legs.
I know, right?
They
I
had
grasp
back,
that, I draw my
Good.
gas and then do a little.
Who said when they fly?
This is
Yeah, why do they
really,
have so many legs? No, a lot of legs.
this is really.
Oh, exactly. You do this.
Okay, I'm ready. All right. Yes.
Come here, bad
Send it
time.
in and I'll get you the quiz.
How do we know which? Caleb talked to me.
You would find one that has sine and cosine in it. And it's sine squared plus cosine.
What?
Can you,
Caleb caught me at a bad
can you
time.
stay after if you don't finish or?
Yeah, I can.
Okay, perfect.
Okay, and then do you like this?
Yeah. Do you want to just set your phone up there? All right, we have 2 people taking a quiz, so we need to be quiet, okay?
I hope so. Sounds pretty good.
We get to get her wallet for her backpack.
Yeah, hey. That's a good idea. Never know.
Are we talking about somebody in this room?
No, definitely not. There's just someone going to get Subway
Right now.
right now.
Dots, you see that?
Jordan?
Well,
I would
it could be anybody.
She would not.
I know you did.
1, 2.
I know Alex did.
Yeah. I think there's 27 of us, right, Bob? 1, 2, 3, 4, 5, 6, 7, 8.
Let's round up again.
27 including Nolan, but no one's not here, so 26.
You guys are not bringing stuff, so you don't have to worry about
We're
that.
not.
We know
We're not bringing anything.
I know.
Or not right now. We're not bringing anything.
There's no, round up to 30.
I do that.
Hey, why'd you say 30? Because we dropped it off.
What do you mean by that? What do you mean by that?
He's making all the subs for us, right, Luis? He's making all the subs for us.
All right, take a seat on.
You know the roasted chicken breast? Good. That's so good.
I don't know about you, man. I can't do it.
I'm just gonna say, if you guys bring anything
We're
on
not-
Tuesday or Wednesday, it's not coming in this room.
This isn't,
So-
this isn't. the
Or
hot
Monday.
spot.
Or tomorrow, or tomorrow, okay?
Can we eat in the hallway?
Okay, Owen,
Aaron, that is the best bread. That is
sit.
the best bread.
Hey, Owen, Monday?
Okay, you cannot bring anything today, tomorrow, Monday, Tuesday, Wednesday.
Thursday?
Thursday, we don't have school. So-
Can you open up the school?
I can't.
Whole row, scoot forward. No one's desperate to do it.
Matt, you'll have to bring the brownies for that. History.
There we go, got it.
Normal.
I just feel like love my home.
I might not be here tomorrow.
Okay, so I have a worksheet for tomorrow.
No, I'm not gonna spell her name right.
Okay. And then I'll put the video on for you, okay?
What are you doing?
Hey, yo, what up, background Subway?
Oh, shoot.
I didn't bring back someone, but
Where'd you start?
Advanced Algebra 2.
Oh,
Fine, I never got a word.
I was just right after Andy got the word.
You never got a worksheet?
You guys actually sent your orders.